why are we all here? Not philosophically, why are we here, but why do we keep coming to Transform, to Rochester, year after year? I think it's because we care. Well, the clicker here. There we go. We want to affect change. We want to affect change in healthcare, and because we believe that we can actually do that. So we keep showing up to the conference year after year. And when we think about building an ecosystem for health, how much progress have we really made with that? Or have we actually innovated, or have we just kind of picked off low-hanging fruit when we think about the innovation work that we've done? And where does that innovation come from? You know, we're continually asked to innovate as designers and thought leaders, but does it come from our own minds, or does it come from design? Oftentimes we turn to design, human-centered design, design thinking, our tools that we start to think about, the things that we use. We think about processes like service design and things like that. And those are really awesome at identifying those, the people that have those challenges that we're going to help figure out how to solve for. And they're really good for defining unmet needs and those challenges that those people do have. But when we get to the innovation space and the ideation space, when we actually have those challenges in front of us and start to think about those and leap into that ideation space, it kind of sucks. It doesn't, those methods don't really get us where we need to be with that stuff. And they usually lead to a design team standing in front of a whiteboard trying to come up with ideas. And the problem with that is that when we're ideating, it always comes from a place of what we know. It comes from what we as designers or team members bring to the table, whatever that baggage may be, whatever that preconceived notion might be about how we're going to solve something. It's just what we bring as human beings to the table. And I've been a designer for about 25 years now, and the question that I keep asking as I'm standing there with these design teams is, how smart are we really? Okay? Does this work? Does doing the things the same way that we've been doing it over and over and using these frameworks really get us to where we need to be? In the ideation space, we see people and teams struggle all the time. So at the firm that I work for, we teach design thinking, we run boot camps. I see people struggling when they're learning it. When we're consulting and we're actually embedded in teams in different organizations, I see those internal teams struggle with it, and I see our own teams inside of Azul 7 actually struggle in this ideation space, again, because it's just working off of what we know. And oftentimes when we're working with these other teams, the folks that may be involved in it aren't necessarily trained designers either, because we're bringing subject matter experts to bear, and those folks are going to have their lens, and they're not used to working in the ideation space day after day. So what happens is, you know, the question becomes, as teams and individuals, do we have the answers? And I question even further, like, should we have the answer? Should we have to have the answer to every design challenge and every problem that's put in front of us? And I don't think we do. I think as design teams, when we think we have it all figured out, when we think we have all the answers to every challenge that comes in front of us, I think we're dead in the water. Innovation exists in this space of dynamic non-equilibrium. It's constantly changing, it's constantly in motion, and I think that if we're going to work in that space, it's super, super messy, it's super organic. Any of you guys that have done that kind of work, you know this. And to work in that space, I think we need tools and frameworks that actually expand our thinking in that environment and not just being based on what we already know or what we think we already know. So, what if we didn't have to have the answers? What if we could be a little bit more humble about how we approach the design work that we do? And what if we could be a little bit more curious in that space when we think about how we're going to approach that work? And what if we could actually look elsewhere? What if there was an infinite library of solutions that you could tap into and pull wonderful ideas from? And actually, what if that library was right outside your door? Well, the cool part is, and the good news is, it is. And it's the natural world. So nature's been innovating for about 3.8 billion years, and it has solved every conceivable innovation problem that we can possibly think of. Things like preventing infections. So porcupines, I don't know if you guys knew this or not, but porcupines have a natural antibiotic in their skin. And they need that because they do porcupine shit like this, right? So and when they're like, hanging out with other porcupines, dangerous things happen. So they fall out of trees and they get scraped up and they get bumped up. So they needed an adaptation of this natural antibiotic in their skin. And then, nature solved problems like cooperating to solve complex problems. What if we could cooperate like leafcutter ants? The cooperation that they go through when they're actually foraging is remarkable, and how they tell each other where that stuff is at, and how they communicate, and how things are passed on is incredible. And they do this in a very complex way. They also have a really cool relationship that they cooperate. They don't actually eat the leaves. They take the leaves into their nests, and they grow a fungus on it. And they have a mutualism with that fungus. So that fungus cannot live without them, and they can't live without the fungus. So what if we in business and in healthcare actually cooperated with other groups in the way that they cooperate and have these mutualisms, right? And then nature's figured out how to be highly resilient and adaptable. The Arctic fox is amazing in the types of environment that it is and the cycles that it goes through every year. This thing changes its coat and changes the weight of it and the color of it to deal with the dark time and the light time. And it changes its foraging strategies throughout the year. So nature's figured out how to do this. And how to do, there's just tons of wisdom there. The wisdom's out there. So what if we actually embrace that wisdom? What if we turn to it in a different way? So imagine if we just went out and observed all that we can learn from 3.8 billion years of iteration. And then what if we actually put that work to work for us, okay? Well, through biomimicry we can. And so through the practice and framework of biomimicry, we can tap into all that knowledge that's out there and that's existing. So what is biomimicry? Everybody's like, okay, what's this guy talking about, right? We define it as the conscious emulation of nature's genius. And those words are picked very specifically. So conscious means that we are going to be very specific in how we approach the biology that's out there and how we track down solutions for these problems. And emulation means that we're not going to bioutilize, we're not just going to copy nature, we're not going to be inspired by it, but we're going to emulate the best things. We're going to learn from that. When we talk about doing biomimicry work, we work in kind of three very distinct areas. We think about form, process, and system. So to define that very quickly, form, why do honeybees use hexagons? Okay, why is that structure, why is that honeycomb structured that way? For one, it's an incredibly strong structure, and two, it's absolutely the most optimal and efficient way to pack a whole bunch of stuff into a tiny, tiny little space. When we think about process, and we look to the honeybees, how do they build it? We would have taken a big giant chunk of aluminum and shaved and drilled and cut into it, right, and left a bunch of waste on the ground. Well, honeybees build from the bottom up. So think like 3D printing, right, additive manufacturing. So they build in that way. And then when we think about process, think about the process inside the hive and what goes on with it. Do you know that every honeybee, other than the queen, actually learns every single job and does every single job inside the hive at one time? It's not just drones or drones, scouts or scouts, foragers or foragers. They all do those jobs. So if something happens to the hive, they can pick up, they can adapt, they can be resilient with how they approach that. We also look at and think about it from a model, mentor, and measure standpoint. So model, that's the emulation piece that I was talking about. But mentor, in the sense that there's so much that we can learn from nature, not just the biology of those things, but there's very deep patterns that continue to show up. And we call those life's principles, and we tap into those all the time. There's about 26 of them that we use. But we also think about measure. Nature measures everything in very serious ways. 99.9% of everything, every species that's ever existed on this planet has gone extinct. So the question is, was that species maladapted or well-adapted? Right? Is your innovation going to be maladapted or well-adapted? And after, it's the ultimate iteration process. And after 3.8 billion years of prototyping, the fossils are the failures. And what we have around us now is the secret to the success. So what if we could actually take advantage of that? Well, we can. As biomimics, we work in the translation space to bring those successes to bear. We help unlock those secrets, and we work in kind of as a functional bridge. So we go out, whatever the design problem is, we go out and look at that, and bring back the mechanism that solved for that design problem. And we bring that back to the design teams that are going to work on that in the innovation space. So I'm going to give you some examples. So sharks are extraordinarily amazing creatures. And some biomimicry folks learned that they get no biofouling. So no bacteria can stick to them. Excuse me. And it's not from a chemical process, it's from a really cool structure. There's these really groovy little diamond structures on the trailing edge of their denticles or their scales that makes it so no bacteria can stick to it. So Sharklet Technologies has actually figured out how to mimic that. And this is probably one of the most well-known ones in the healthcare space. So they figured out how to mimic it, and they can do it either by imprinting surfaces or by creating films that they wrap around a surface. So no bacteria can stick to it up to like a 90% rate. So what if we could actually prevent bacteria from ever being on a surface rather than having to think about cleaning it up with really harsh chemicals in the medical environment, right? And that becomes a very important thing when you think about the fact that about 270 people a day die from healthcare associated infections, okay? So thinking about that, it would save the industry roughly 20 billion annually if we could actually prevent those things from being on those surfaces to begin with. Another one, any fly fishermen here? So caddisflies are also groovy little creatures, and they build these amazing little things called cases. They're little huts that they build underwater, and they're made out of twigs and pebbles. The cool thing about caddisflies, though, is they do it with silk. They're actually a relative of butterflies and moths. Their silk actually works better in a wet environment, and in a biofouled environment. So when we think about that from a medical application, we can do all sorts of adhesives on the outside of us in a dry, clean environment, and those will continue to actually stick in a wet environment if you get them wet, but we can't do it inside the human body. Human body is about 60% water. We can't adhere things inside the human body. So the way that we do that now is by mechanical means. So we stitch it, staple it, bolt it, pin it, plate it, right? But what if we could do that? What if we could actually use something inside the human body in joint tissue or joint bone that it actually works better when it's wet, and it also has an elasticity that the caddisfly silk can actually stretch double and go back, so there's a resiliency and a plasticity to it, but it doesn't snap back. So that becomes really interesting when we start thinking about dealing with tissue, right? Or what if we think about honeybees? So back to how they communicate, and back to the fact that honeybees self-organize when they make decisions. So every year, the hive has to make a really important decision. At some point during the year, the queen is going to split off and take about 25,000 bees with her to go start a new hive, and a new queen comes. And when they do that, they send out scouts. And the scouts come back, and they go out and look for the perfect kind of place to live. There's some very clear criteria around that. But when they come back, the way that they communicate is the same way that they communicate from a foraging behavior. They do a waggle dance. And this waggle dance, when they're cruising around inside the hive, tells the other bees how far away it is, distance, angle of the sun, all these sorts of things. The pertinent data in order to get to the place. But the really interesting part of it is the intensity with which they dance tells how much they believe the site is perfect. So if one bee comes back and it does 20 versions of the dance and it does it really intensely, they believe in it more versus the bee that came back and just did 10 versions of the dance. So as they do this, more and more bees pay attention to the more vigorous dancers, and they start to go to, the other scouts start to go to, and they come back and they start to dance. And dance intensely, okay? So what happens is basically they end up with a quorum, not a consensus. They end up with a quorum, which is enough to say, okay, this is the place to go, and there's another signal that's made, and then they all kick in and get ready to fly off. So it's very, very simple rules on find the optimal place and then follow the best dancer, right? So that comes into play. There's some work going on in Europe around swarm medicine, actually, and thinking about very interesting decision-making processes as we gain more information with the technologies that we have and how we share that information. So looking and thinking about these examples, you can see where that combination of human-centered design, going out and finding the problem, and then looking at kind of biology, nature, and life to help us start to jumpstart our solution space makes a lot of sense. So as designers, I believe that we can change the way that we're doing things. I believe we can do better, for innovators, change makers. I think that it's out there, and we can design much more impactful solutions. And I don't think we have to do it alone. I think that we can learn from all of nature's lessons. Both the successes and the failures can teach us a whole bunch. So, and in the end, to be human is part of nature anyway, so why wouldn't we want to learn from that? So with biomimicry, we can go from a place of standing in front of a blank whiteboard with a stack of Post-its in our hands to actually coming to the design problem armed with a bunch of design principles abstracted from the natural world. We can go from painful brainstorming sessions that often go nowhere, right? We've all been there, to inspiration and solutions that actually energize a team, and it actually jumpstarts the conceptual process when we think about how we're going to solve these problems. And we can go from designing services and products that actually have negative impacts on a system to solutions that are actually regenerative and resilient and contribute to the system as a whole. It gives you another framework that's actually rooted in science and 3.8 billion years of evolution to tap into. It gives your teams much broader ideation space for innovation and greater inspiration for solutions that are out there. And it also puts them in a much better mindset of solving those solutions in context for the users and the environment. And it gives us innovations that are regenerative and resilient for the systems that they operate within. And it's innovations that fit into the new ecological age rather than the fading industrial age that we're in now. So back to why we're here, change. Changing a system is really hard, and the best way to do that is to think about changing the paradigm that you're in. And if we're going to change the paradigm of how we design, we have to rethink that, and we have to be willing to rethink that. So where and how do we begin that? I think that part of that, it's really daunting in rethinking how we design things, and I think we have to have the courage to quiet our cleverness and look elsewhere for those answers, and to look to nature for those answers. So where do we start? Next design project you're going to be on, where do we go? We begin out here. We begin learning from the natural world. We reconnect with that and learn those lessons from the library that we're actually a part of. So the combination of human-centered design and biomimicry actually is the only way I believe that we can design the future that we want. And I think that it's a future that's resilient and regenerative, but it's also empathetic. It's empathetic to the people that we're trying to solve for, but it's also empathetic to all the other organisms that we share the planet with. And if you look at it like that, as designers and innovators, we actually have a responsibility to design that way. So in the end, I guess I can't think of a better model for an ecosystem of health and designing one than the one that's right outside of our door. Thank you. Get outside.